Hello, thank you for watching this video. So in this video, I'll be doing question 5 of November 2021 question paper mathematics paper 2. The topics is the trigonometry. So these are trigonometric principles. So I'll start with 5.1. So we go. So 5.1 reads as follows. Without using a calculator, simplify the following expression to one trigonometric ratio. So they've given you this thing here. They want you to simplify it to a single trigonometric ratio. That's what they want you to do. So in order to do this, this is what you need to be familiar with. You need to be familiar with this. You need to be familiar with this. So from 0 degrees, 90 degrees, of course, 180 degrees, 270 degrees, to 360 degrees. Right? No problem. So, you need to consider this. So, in this quadrant, the angles are from 0 to but less than 180 degrees. So, in this quadrant, the angles are from 0 but less than 90 degrees. So, your angle x is from 0, greater or equal to 0, but less than 90 degrees. No problem. Another way you can write this, you can say, okay, if your x is here, the angles here are 90 degrees minus x, which is that less than 90. Right? Here, this side, the angles are greater than 90 degrees. Because if you add any value that is in this interval, it will fall on this. Right? And then here, at the same time, you can say these angles are less than 180 degrees. In the third quadrant, the angles are greater than 180 degrees. So you add that. But at the same time, they are less than 270 degrees. On the fourth quadrant, the angles are greater than 270 degrees. But at the same time, they are less than 360 degrees. That's the first thing that you need to know. Second thing that you need to know is that your three ratios, which is your sine x, your cosine x, and your tangent of x, you need to know the signs of these three functions on all of these four quadrants. That's what you need to know. So how do you go about this? So I'm not going to show where this is coming from because I'm not teaching here. I'm just answering the question, or I'm preparing you so that you know how to answer this question. I would assume this is the knowledge that you know already, but if you don't, maybe on a day when I'm teaching, then you might be able to know that. But on the first quadrant, this is the first quadrant, right? This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. On the first quadrant, all of these functions, all three functions are positive. So your sine x, your cos x, the tangent of x are all positive, which is greater than 0. That's what you need to know. On the second quadrant, only one function is positive. The sine of x is positive. The rest are negative. On the third quadrant, the tangent of x is greater than 0. The others are negative. On the fourth quadrant, the cosine of x is greater than 0. The other two ratios are less than 0 on the fourth quadrant, only cosine. So the red ones that are the red written functions are positive in the quadrants in which they are written on. So if you see all three of them written on the first quadrant, what that means is that all those trigonometric ratios are positive on the first quadrant. On the second quadrant, this sine x is positive. On the third quadrant, the tangent of x is positive. On the fourth quadrant, the cosine of x is positive. That's what you need to know. So, when you are given something like this, you can see this, whatever. So, in this case, I'm taking your x to be an acute angle, which is less than 90 degrees, or on this interval here. So, I'm considering x as to be an acute angle. That's what I'm doing. So, what you need to do is to write all of these things as acute angles, which means all these angles, 140, 360 minus, and this one is acute angles, right? This one is already an acute angle. One would want to argue that this one is an acute angle, but it's a different direction. So, but I don't want to work with many directions. I would like to work in one direction, which is anti-clockwise, from 0 to 360, but not from 0 to negative 360. So, in this case, I'll take this as non-compliant or as inconsistent with this direction that I'm trying to stick to, because I notice that many students are comfortable with one direction, so I'm not going to use many directions so that I explain many things. I'm going to stick one. I'm going to choose one and stick with it. In this case, I'm choosing the anti-clockwise direction. So, what do? We need to write this 140 as an acute angle, which is as an angle that falls on this interval. How do we do that? This is what we do. So I'm going to use the blue ink now. You say, okay, now you rewrite this sign. So you say sine. What is this? This is 140, right? This is what? 140. So you need to write this 140 either this way or this way, because 140 degrees is on this quadrant, on the second quadrant, because 140 degrees is between 180 and 90 degrees. So it is on this quadrant. Look at that angle, it's 140. So 140 is on the second quadrant between 90 and 180. So you have options. You can write your 140 as 90 plus something, or you write your 140 as 180 minus something. Right? No problem. So I'm going to write this 140 as 90 plus 50 degrees. So this now is the same as this one. Times, I'm going to write this as is, sine 360 minus x, all divided by sine 50. There's nothing that I'll do with this sine 50. Why? Because sine 50 degrees is an acute angle. It falls on this interval already. So there's nothing to do with it really. It's finished. Instead, we want to write everything to look like sine 50, so that this angle here is an acute angle, which is an angle between from 0 but less than 90 degrees. No problem. So times the tangent of negative x. So one would make a case and say that negative x is okay, right? I would not fight with that person, but I'm not happy with the direction of negative x, because I would like to stick to this direction. So in any case, if you see something that is less than an angle that is less than 0, add 360 to it until it becomes positive. So on this x here, I'm going to add what? 360. So I will have the tangent of plus 360 minus x. So I've just added 360 there. There is it. So this one was negative. So I like it better this way. No problem. What do we do on step 2? Let's go to step 2. So step 2, you are simplifying these things now, all of them. This one, and that one. There's only 3 that you need to simplify. So let's go. What do you say? You say, okay. You ask yourself some questions. Where is 90 plus 50 degrees? 90 plus 50 degrees is 140. 140 is where it's on the second quadrant. Right? No problem. We found where it is. What sign is this function? Sine, which is the function that we're given on that quadrant. Our sign there is what? Is positive. No problem. We take down the sign of our function. It will be positive. No problem. But this is what you need to know. If the maximum here falls on the vertical line, if the maximum falls on this vertical line, or this vertical line, it's either 270 or 90 degrees. A function, whatever function that you have, will change to its cofunction identity. So, for example, if you were given sine x, right? If you're given, let me say, sine 90 minus x, you're going to ask, where is 90 minus x? 90 minus x is on the first quadrant. No problem. What sign is this function? Is sign there? Sign is positive because it's written there. It's positive. So what happens is you say, okay, sign is positive. There it is. So this sign of yours will change to its cofunction identity, which is what? Which is cos x. So it will change and become cos. But if you had cos 90 minus x, you ask yourself, where is 90 minus? 90 minus on the first quadrant, as you can see. Which means no problem. What sign is this function? That sign there is positive. That function is positive, which is cos is positive on the first quadrant. So this cos of yours will change to its co-function identity, which is what? Which is sine x. Same thing, you can go to tangent of 90 minus x. Where is 90 minus? It's on the first quadrant. What sine is the tangent of, what sine is the tangent of on the first quadrant? It's positive. So this will change to its co-function identity to become what? Cot x. This is what you will have. So the point what I'm trying to make is that if you have 90 degrees or 270 here on this position, 90 or 270, the function will change to its co-function identity. That's what we need to know. Let's go back to this. So here, your maximum is 90 degrees, right? So if your maximum is 90 degrees here, which means this function sine will change to its co-function identity, which is what? Which is cos. So this will become cos what? This will become, so this should be cos 50, sorry. This was supposed to be cos 50. So it's still okay. It's not a problem so far. Cos 50, cos 50. Not a problem. So what do? We say now, okay, so I'll ask the questions again. Where is 90 plus 50? 90 plus 50 falls on the second quadrant. What sign is sine there? Sine x is what? Is positive. So I've taken down the positive sign. Then, but because the maximum falls on that vertical line, it's 90 or 270. In this case, it's 90. This function will change to its co-function identity, which is what? Which is cos. So we'll have cos 50 here. This is 50 degrees, not 56. Times 360 minus. Where is 360 minus? 360 minus is on the fourth quadrant, as you can see there. No problem. You ask yourself now, what sign is sine on the fourth quadrant? On the fourth quadrant, only cos is positive. Sine is what? Is negative. But because now your maximum is not on the vertical, it's on the horizontal. Because you can see your 360 is on the horizontal. So your function will not change to anything. It will remain the same. So you will have negative sine x. Negative sign of that. No problem. All over. Go to the next one. Cos 50. Cos 50 is already an acute angle. So we'll have your cos 50 here. Times. Go to this. Where is 360 minus? 360 minus is on the fourth quadrant. It's here. There is it. Then ask yourself, what side is the tangent there? On the fourth quadrant, you can see here, only cos is positive, which means the tangent is negative. So you put the negative sign for the tangent. Negative for the tangent. But because your maximum is horizontal as it was here, the tangent will not change to its co-function identity. It will remain the same. You'll have the tangent of x. Right? So this and this, they cancel out. Right? So what we're left with? We're left with negative sine x divided by negative the tangent of x. The signs cancel out as well. What are you left with? Now we're left with sine x divided by the tangent of x. This is the same as that. Right? No problem. But you know that from your trigonometric classes that this idea that the tangent of x is equal to what? It's equal to sine x divided by cos x. You need to know this identity. It's what we're going to apply here. So what do? We say, okay, sine x divided by tangent of x, which is sine x, over cos x. Then we change this multiplication, this division to a multiplication sign by flipping this around. So your sine x times cos x over sine x. So this and that go away. what we're left with, we're only left with cos x. This is it. We're done here. All what you needed, we apply those principles that are over there. And you needed to know this identity here. The tangent of x is equal to sine x over cosine of x. No problem. We're done with this one. Now we're going to the next one, which is 5.2. Okay, so now we're given this thing here, right? So what are they saying? They are saying now, prove the identity at 5.2. They wanted to prove this identity, that negative 2 sine squared x plus cos x plus 1 all over 1 minus sine cos 540 minus x is equal to 2 cos x minus 1. That's what they wanted to prove. So the first thing that you do, you choose which side you think you'll be able to work with. That is on the simplest form. I don't know how can I transform this to this, but I can try to transform the complex one to that simple version of it. So let's take the left hand side. So we want to prove now that the left hand side will simplify to that. So how do we do that? We say, okay, we have minus 2 sine squared x plus cos x plus 1 all divided by 1 minus cos 540 minus x. This is what we have. So what do we do? You can see there's cos, there's 1, there's sine squared x. So what you want to do, you want to make sure that all your functions look similar. All your trig ratios look the same. Or your trig functions or trig ratios, they look the same. So because this is sine, there are a lot of cos's around. So what you want to do, you want to change this so that it looks similar to this, or maybe similar to that as well. No problem. But the issue that we have now is this one over here. So let's just get rid of this big angle here and make it an acute angle like those ones. We're going to use the same principle that we used from this step to this step down here. So let's deal with this part first. So I'll write the top part as is and say, okay, minus 2 sine squared x plus cos x plus 1 all divided by 1 minus, you ask yourself, where is 540 minus x? 540 minus is not on this thing, right? It's not here. Our maximum is 360 there. So what we do, we subtract this by 360 until it falls on this interval. So which means subtract this 540 by 360 and see what you get. You'll see if you subtract 600, from this 540, if you subtract 360, the answer that you'll get will be 180. So subtract 180 here. Sorry, subtract 360 here. So the point that I'm trying to make is that if this number, this maximum that is here, is above 360, subtract 360 to it until it falls on that interval. If it's below 360, it's negative. You must add 360 to it until it falls back up to this interval. If falling back makes sense. So what do you do? So subtract 360 there. You will see that you will be left with cos 180 minus x. Because you subtract 360 on this one. So this looks familiar because at least it falls on that interval and it's on the second quadrant. So what you do? You apply this logic here. So you say, okay, I have minus 2 sine squared x plus cos x plus 1 all over this thing here, which is 1 minus whatever this thing is. So what do you say? You say, okay, here I have 180 minus, where is 180 minus? 180 minus is on the second quadrant. No problem. The second question is, what is the sign of this function on the second quadrant? On the second quadrant, only sign is positive, so the other functions are negative. So this thing is negative. So I'm going to put negative here. Negative sign here. No problem. Then what do we do? Then now, because this is horizontal, it's on this horizontal line, the function will not change to any co-identity. the function or the trig ratio cos will not change to its cofunction identity, right? It will remain the same. So we'll have the cosine of that acute angle x there. And then we can simplify this, and this will become minus 2 sine squared x plus cos x plus 1, right? No problem. All over 1 plus cos x. This is what you have now. Because it will be this times this and be positive, so it will look like this. No problem. I think we are done with the complex things now. So let's look at it. If you look at it, you will see very quickly that we have a lot of cos x's there and 1 sine squared x, right? So the trick is you should try to make this 1 minus sine squared x similar to these ones. How do we do that? There's another identity that I'm sure you know by now. It says, okay, the sum of square of x of sine x plus the square of this trig ratio is equal to 1. You know this, I'm sure you've seen it many times. The sine squared x plus cos squared x is equal to 1. So from this, we can solve for sine squared x by transposing this to the other side. So you get that your sine squared x is equal to 1 minus this, minus cos squared x. So maybe I made this arrow very big. So I said we are solving for sine squared x, which is what you have here. So your sine squared x is equal to 1 minus cos squared x. So, which means where you see your sine squared x, you put that identity there. So at least they will all look like cosines, right? So what do you have? You say, okay, minus 2 into sine squared x. My sine squared x is equal to 1 minus cos squared x plus cos x plus 1. All divided by what? All divided by 1 plus cos x. No problem. So now we're here. But what we need now, we need some space, right? We need a bit of space. So what I'm going to do, I'll try to clean the board so that we can have that space. What are we cleaning? I'm going to clean this side. 5.1 here. I don't want to clean the other side because I worry that we might need it, or we might need some information there. No problem. So, what do we say? Now we simplify this, so it will be 2 times 1, or negative 2 times 1, and negative 2 times that. So what we'll have is 2 minus what? Minus, actually it's not 2. This time this is negative 2 minus or plus, this time that, plus 2 cos squared x, right, plus cos x plus 1, all divided by what? All divided by 1 plus cos x. No problem. Simplify this and this are like terms. Put them together, so you have 2 cos squared x plus cos x, which is this and this, here they are. Then add these 2, so negative 2 plus 1 becomes minus 1, all divided by what? 1 plus cos x. Right? No problem. So what do we do from here? We say, okay, we can try to factorize the top there. I'll try to make it easy and say let your cos x equal to k. Let cos x equal to k. So what we have here is 2k squared there plus k plus 1 all over 1 plus k. This is what we have at the bottom. Then we try to factorize the top. So if we try to factorize the top, we can say, okay, the factors of this is 2k and k, and then we have 1 and 1. So Actually, this was supposed to be minus 1 because it's negative there. So this times 2k times k is k squared. This times this is 1, right? But because this is negative, we know that these signs will not be the same, right? So one should be negative and the other should be positive, but we're not sure which one. We say this times this, it gives us 2x, right? This times that, it gives, it gives us 2k. This times that, it gives us k. So the bigger cross multiplication, take the sign of the middle term. So the middle term is positive. So this times this gives us 2k. So this is the bigger cross multiplication, right? You should take the sign of the middle term. So this times this should be positive. This times that should be negative. So in that case, we'll have this time this positive 2k. This time that it will be negative k. When you add them, they give you k, which is the middle term there. So these are the factors that we're looking for. In that case, the factors that we have at the top is 2k minus 1 and k plus 1, right? All over 1 plus k. So k plus 1 and 1 plus k is the same thing. So these two go away. So what you're left with 2k minus 1. But what is k? Your k is cos x. So you're left with 2 cos x minus 1. And what you see here is equal to what you were given initially, which was your right-hand side. So we've proved this thing. We're done with it. And I hope it does make sense to you the way it does to me. And I'll try to clean the board and go to the next question. I hope you are still following. The reason I allowed cos x to be k is because I know it's easy to factorize with x or k rather than having the whole thing there. So it's easier if I allowed it to be k. So we're done here. Let's go to the next question. I'll clean this board and this part, and then we'll do 5.3, and we'll be done with question 5. Okay, so now we're doing 5.3. So I've cleaned the board, including this side. Turns out I won't need any of that information anymore. So let's go. 5.3. Given that sine 36 degrees is equal to the square root of 1 minus p squared, without using a calculator, determine each of the following in terms of p. Let me read this thing again. Given that sine 36 degrees is equal to the square root of 1 minus p squared, without using a calculator, determine each of the following in terms of p. So at 5.3.1, we're given, they're saying determine tan 36, the tangent of 36. So you are given sine 36 to be that, right? So the first thing that you need to draw a rough sketch of this situation. You need to have a rough sketch so that you can at least try to have a visual of what is happening. So how do you do that? Draw your Cartesian plane. So you have 0, you have 90, you have 180, you have 270, you have 360. Right? So this is the first thing that you do. And then look at the angle and identify which quadrant you are on. 36 degrees is an acute angle, and all your acute angles are on the first quadrant. Right? All your acute angles are on the first quadrant. So what do? You draw a right angle triangle on the first quadrant, like this. There is it. It's 90 degrees there. And here is your angle that you are given, which is what? 36 degrees. And this is 90. And you know that angles in a triangle are supplementary. So they should add up to 180 degrees. So this angle up here, you say, okay, your 36 plus 90 degrees plus your angle, your unknown angle, A, is equal to 180 degrees. So if you solve for your A, you find that A is equal to 54 degrees. So here you have 54. Not a problem. Then you get that sine 36 is equal to square root of 1 minus p squared, right? You know that your sine, the trig ratio for your sine maybe theta is opposite over the hypotenuse side. Right? No problem. Which means this is your opposite divided by the hypotenuse. But when you look at it, you don't see anything dividing it, because what is dividing it is 1. You should know that. What is dividing it is 1. So which is the sine 36 degrees is equal to square root of 1 minus p squared all over 1. Because you know it should be like this. Because it should be the opposite over the hypotenuse side. So there is your opposite, this is the hypotenuse side. So your opposite to this angle is that side over there, which is, this is the square root of 1 minus p squared. And your hypotenuse is the longer side of a right angle triangle, which is this one. So what you don't have is this side over here. But because you have a right angle triangle, you can use Pythagoras. So let's do that. And say, okay, the hypotenuse, the square of the hypotenuse is equal to x squared plus y squared. Hypotenuse is 1 squared is equal to x squared. What is your x squared? Is what you're looking for. X squared plus your y squared, which is that. Square root of 1 minus p squared, all squared. This square is that one. This is your y value, which is your thing. So this and that go away. So what are you left with? You're left with 1 is equal to x squared plus 1 minus p squared. Solve for your x, transpose this to this side. You have 1 minus p, actually, you have 1 minus 1 plus p squared is equal to your x squared. So this and that go away. Therefore, your x is equal to plus or minus p. So whatever p is the x value which is on the right hand side of 0. So this is positive. So your p is greater than 0. Therefore, x is equal to p. So you have p here. Once this triangle is full, right? Once you completely filled this triangle, let me clean this so that you can see. So here is the triangle now. You have all the information. It's a bit easier now because they want the tangent of 36. So you know that the tangent of 36 degrees now is equal to your opposite side over the adjacent side, right? And if you look at the triangle, the opposite side is that one, which is square root of 1 minus p squared all over the adjacent side. The adjacent side is the next two sides, which is p. So it's p. We're done with the tangent of 36. Then you move to the next one. The next one, what is it? They say 5.3.2. They are saying now, determine without using calculator each of the following in terms of p. So they want you to find cos 108. This is what they want you to find. So what you need to do is to relate this to any of those triangles that are there, to any of those two angles that you have there. No problem. But if you look at 108, it is double of 54. So if you say 54 times 2, you get your 108. So your cos 108 is equal to cos 2 times 54 degrees. And if you look at this looks similar. This times this, 2 times an angle. It looks similar to a double angle, which is 2a. Your cos 2a, you know it very well. It's equal to cos squared a minus sine squared a. Or you can say 2 cos squared a minus 1. Or 1 minus 2 sine squared a. So it can be any of the three. So take whatever that you think will work well for you and stick to it. So in any case, I'll take this one myself and say this is equal to 2 cos squared 54, because my angle is 54, minus 1, which is equal to the cos 108 is equal to 2 times cos 54 all squared minus 1. What is cos 54? Go to a triangle. Is the adjacent, your cosine of 54, right, is the adjacent side, right, over the hypotenuse. So the adjacent side of 54 is this one here, which is square root of 1 minus p squared all over hypotenuse, which is 1. So the cosine of 54 is the adjacent side, which is this. This is the adjacent side to 54 over the hypotenuse. So if you simplify this, this and that go away. So you're left with 2 into 1 minus p squared minus 1. And this becomes, what do we have? We have 2, we have cos 108 to be equal to what? 2 times 1 is 2. 2 times p is 2p squared. Then that minus 1 at the back, minus 1. Therefore, this cos 108 is equal to 2. 2 minus 1 is 1 minus 2p squared. So your cos 108 looks similar to this thing. Looks similar to that. So I think we're done here, and I hope it does make sense to you as it does to me. Thank you for watching. Cheers.